Okay, so we're going to take a couple of minutes and take a look at a few more notes here real quick, which is basically the last of the stuff that goes along with the basics of how to solve equations. Now, that doesn't mean you have like a test tomorrow, but it does mean that we have gone through a lot of the things about equations. And so far, we've learned about how to solve basic equations by basically, like subtracting and dividing, and that's pretty much it. We figured out that if there's parentheses, you've got to distribute first. If you have like terms, you need to combine them first and make them look like everything else. And if you had stuff on both sides, you need to get all the x's on one side and the numbers on the other before you finish things off. So all of that basically boiled down to what you were doing on that worksheet that we went through today and what other people were writing for their equations. And I know some of you are still working on the other people's equations. That's great. Okay. But I want to make sure that we get through the rest of what we got to, and it's pretty straightforward. So we're going to take a look at a couple of equations here. And I want you to kind of look at these for a minute and see if you can figure out what's up with them. And it's not too hard to figure out that, of course, what you're going to have to do is like distribute. I mean, that's pretty straightforward, but there's a problem. So what is that problem? So for the top one, both sides has 6x, kind of like that, right? And what's more, that happens on the bottom one too. It's actually 10x rather than 6x that you get on the bottom. But the point is you get the same number of x's on both sides on both of these problems. And so remember when I said you picked the smaller number of x and subtracted on both sides, there is no smaller number of x on either of these problems. And that means we got an issue. And that's what we're going to talk about today is what happens when you have that same number of variables, and essentially what happens is the variables cancel out. And basically one of two things is going to end up happening. One of them is what happened actually in the second problem that I wrote down there, where you have like 10x minus 15 equals 10x minus 15 once you distribute the stuff out. If everything is exactly the same, what we end up saying is that there are infinitely many solutions, or the solution is all real numbers. It basically means you could tell me any number you wanted to, and that's going to end up working out in the problem if you try it. Okay? You could put in 1 and it'll work out. You could put in 27 and that would work out. You could put in negative pi and that would work out. No matter what you pick, you're going to get an answer that's correct on these. And again, the dead giveaway for that is not only are the x's the same, but so are the numbers after you do the distributing and put everything together as it's supposed to be. Seeing a bunch of people busily writing, so I'll wait before I go forward. But I will tell you on the next screen, they give you one other term that your book sometimes uses for those, which is that they call it an identity. And an identity is just something that's always true, which is exactly what's going to happen in this problem. So any number we pick will work as long as everything is exactly the same on both sides. That's really the key to when that happens. And the first one that we had that had the 6x's is actually kind of the opposite, which I'll get to in a minute. But again, if everything's the same, both the x's and the number, we would have, what I usually write is all real numbers, but again, you could say there's infinitely many solutions. Again, I'm just waiting. We've got people that are very busily writing, and I want to make sure that they do get everything. Yeah. When are we what? Well, they're still taking it this week for the STAR test, so I'm betting. I mean, honestly, I could look them up, except that my login's not working right now. So probably next week, though, will be when we say that for sure. And again, you can call that an identity if you do have everything that's the same on both sides also. All right. Anybody have an idea what we would say on that first one where it said 6x minus 14 equals 6x plus 11? Is that one's not going to end up being an identity. Yeah. Say it again. You're exactly right, actually. That is what we're going to say on those. And that's exactly what's on the next screen that I'll put up here in just a second. So yeah, if the numbers are different, but the x's are the same, then what's going to end up happening is we do have no solution. And that is exactly what happened on that first example that I put up there. When you multiply it out, we've got 6x on both sides, so the x's would cancel, but the numbers are different. And the very fact that negative 14 doesn't equal 11 kind of tells you that can't happen. No matter what you try, it's never going to work out. So again, it is going to be no solution. Typically, problems that will do that, they're going to start off looking kind of like the last ones that you did on that worksheet, where they'll have x's on both sides, but almost always they will also have either parentheses or like terms in them, because that's how you kind of hide that there is a problem with it. And you do need to think what happens when you distribute out the parentheses. And if the x's end up being the same, that's basically your clue that we're going to have to do some more work here. And again, the whole idea is that if the numbers are different, it's no solution. But if the numbers are the same, it's infinitely many solutions or all real numbers. Okay. I usually just write all real numbers. I find that easier, but your book does like infinite as well. It's the same thing. So any questions that people have with those? Basically getting that part all right. So that's the last part that we're going to talk about with solving equations. We're actually going to wait till tomorrow to do some problems with those. We'll leave it at that, but I did want to go through the last of those notes and call it good.